Hello everyone. Today we are going to study about finding the last two digits of an operation.
Good day everyone. Today me, Milind Chakraboorty from grade 8, 13 years old from India is going to teach you a method for finding the last two digits of a number. This does not mean that you find 3 into 18. It's 54 can be said directly. But if someone asks, whole to the power 2407, then it's a confusing thing. So, for such questions, we have a method called Binomial Theorem method. The Binomial Theorem method. I'm sure most of you would be thinking that, oh gosh, I have to learn the Binomial Theorem too. I think you're mistaken, because you just have to remember a formula obtained from the Binomial Theorem, or I would say a result of the Binomial Theorem, that n gives n to the power n minus 1 plus b to the power n. This formula helps in obtaining the last two digits of a number. Okay, now you can see that we don't know what's a plus b here. We had the question 64 to the power 2407. Now, we don't know how is this written as a plus b. We don't know. But we know that the power 2407 exists there. Whatever be the value of b, any number to the power 2407 is nearly impossible to find. So, for this, finding these things, we have a concept called cyclicity. Now, many of you will be wondering what this term means, right? Okay. This is the word cyclicity. And this cycle resembles to cycle. Now, whenever we are talking about cycle, it tells about repetitions. So, cyclicity. How will we define cyclicity? Cyclicity is increment in powers causing repetition in digits. Okay? This is what cyclicity tenth digit is a little complicated because it needs to have a big observation table that we'll study in further part of this tutorial. But I'm just talking about the unit digit cyclicity for 6. Now, it's 6 to the power 1 gives 6. 6 to the power 2 gives 36. 6 to the power 3 gives 216. 6 to the power 4 gives 1296. And 6 to the power 5 gives 7776. Can you see? Increment is of plus 1 in the power. 1 plus 1, 2. Unit digit remains same. Therefore, 2 plus 1, 3. Unit digits remain same. 3 plus 1, 4. Unit digits same. And 4 plus 1, 5. Unit digits same. In this way, the unit digit cyclicity would continue. As there is a plus 1 increment for the repetition of digits, cyclicity of 6 for unit digit is equal to 1. Got it? Now, we take another example. 2 to the power 1 is equal to 2. 2 to the power 2 is equal to 4. 2 to the power 3 is equal to 8. 2 to the power 4 is equal to 16. 2 to the power 5 is equal to 32. 2 to the power 6 is equal to 64. 2 to the power 7 is equal to 128. 2 to the power 8 is equal to 256. 2 to the power 9 is equal to 512. And 2 to the power 10 is equal to 1024. Now we can see what's happened. This is at the unit digit. Now can we see another 2 at the unit digit? Yeah, at 5. Means 1 plus 4. Increment of 4 powers is there. 5 and the unit digit repeats. Similarly here, 2 plus 4 is 6. 2 to the power 6 has the unit digit same. Means there is an incrementation of plus 4. Here, 5 plus 4, 9. 9 has 2. 6 plus 4, 10. 10 has 4. Similarly, there will be 8, 6, and again 2. So, incrementation of 4 is there. Therefore, the cyclicity of 2 for unit digit is equal to 4. I think till now you will have understood what is the concept of cyclicity. Now, before learning what's the 10th digit or last 2 digit cyclicity, we would learn the only difference, or I would say the basic difference between the cyclicity of unit digit and 10th digit. In unit digit, we can say, actually these differences are based upon NAB to the power n minus 1 here, not here. There must be some reason for it, because 2 to the power 2 has 4 as unit digit. And 32 to the power 2 also has 4 as the unit digit. To prove it, the square of 32 would be 1024. 1024 is 32 square and it has 4 as the unit digit. Now we'll move forward towards the tens digit. In this way it does not exist, and in this way it exists because 6 to the power 7 has 36 as last 2 digits. But 36 to the power 7 does not have 36 as last 2 digit, but 96 as last 2 digits. It does not have 36 but 96 as the last 2 digits. Now, this point must be clear, right? Now, 96 as the last 2 digit means when we are talking about the unit digit, by seeing n digit numbers, we can find the last unit digit. But here, this cyclicity for last 2 digit only work from the numbers 1 to 9. Therefore, we have to divide this number in a plus b equal to the power n. We have to divide it. How will we divide it? We'll study later, or I would say 30. It would be divided 30 plus 6. And we can see the power comes only on b, that is 6. And as it is a unit digit, therefore we can find the last 2 digits. The method we'll learn later. Now, what to do is, as we can find the last 2 digit, now our concept has been cleared. That in a plus b, when dividing the number into a plus b whole to the power n, we have to take b as a single digit. Otherwise, the formula won't work for cyclicity, right? Now we will go towards cyclicity for last 2 digits. See, for learning this, you would first learn an observation table. Then the conclusion table. With the observation table, by observing this table, we find this main conclusion, and I call it the conclusion table. So, we are going to learn both of these tables now.
So, this is the observation table. So, first we talk about 6. First is 0, 6. Second is 36. Third is 16. Fourth is 96. The last 2 digits for fifth is 76. Then comes 56. Then again comes 36. See, 6 to the power 2 repeats again at 6 to the power 7. This means 6 to the power 6 is the repetition for 6 to the power 1. But it's 56 instead of 06. Means every repetition of 6 to the power 1 excluding 6 to the power 1 is 56. See here, 6 to the power 6 plus 5 is equal to 11. and it's again 56 instead of 06. Now we'll see about 5.
05, then 25, then again 25, then again 25. That means repetition is coming after 1 power. So every repetition of 5 to the power 1 excluding 5 to the power 1 is 25, and here every repetition of 6 to the power 1 excluding 6 to the power 1 is 56. There's another pair like this, 2. See, there's no repetition of 0 to anywhere, but here 21 is 52, and we would see that 22 would be 04. Then it means after 20 powers x to the power 2 is repeated as 04. Means x to the power 21 should be 02, but it's 52. Means every repetition of 2 to the power 1 excluding 2 to the power 1 gives 52. These are some little points which one should remember. And you would think we have to remember all these 20 powers. No, a method that I use for remembering the powers of 2, 3. Just remember the powers of 2, 3, and others we can use them easily. Remember 2 to the power 1, 2 to the power 5, 2 to the power 10, 2 to the power 15, and 2 to the power 20. Like if we have 6 to the power x to the power 8 we have to find. We know x to the power 5 or 2 to the power 5 is 32. And what would be 8? 32 into 2 to the power 3. We know it's 8. Multiply it. 8. The last 2 digit would be 56. We know. A little multiplication is there. If you can remember all these, then it's no problem. But if you can't, this method I use. Similarly, you can use here for 3. 3 is 20 repetition. 7 repeats after 4. 8 repeats after 20. Now 8 and 4. We can go easily with them. Like if you have to find x 4 to the power 5, we can write it 2 to the power 10. Now you can see it's 4 to the power 5, that is equal to 2 to the power 2 whole to the power 5, that is equal to 2 to the power 10. And now we can find this by the cyclicity method of 2 to the power 10. Similarly for 9, if we have to find 9 to the power, for example 8, that is equal to 3 to the power 2 whole to the power 8. This would become 3 to the power 8 to the 16, 3 to the power 16. And we can find this by the cyclicity method of 3. It's so simple. And we can remember for 6, 7, 8. Now 8, it comes for 8. 8 I think you would have understood by yourself, but I should tell. 2 cube, it's equal to 2 whole to the power 18. And we can find this by the cyclicity method of 2. Now we can learn all the cyclicity. The observation table you can get in my website. The PDF file that I have uploaded, it's written below. Now digits. Now we are going to know what are the cyclicity in table form. 2, 3, 8, it has the cyclicity 20. 4, 9, it has the cyclicity 10. 5 and 1 has the cyclicity 1. 6 has the cyclicity 5, and 7 has the cyclicity 4. Whichever points we have discussed, that 2 to the power 1's repetition should be 02, but when we analyze the above table, it says that every repetition of 2 to the power 1 excluding 2 to the power 1 is 52.
and 6 to the power 1's repetition should be 06. But when we analyze the above table, it says that every repetition of 6 to the power 1 excluding 6 to the power 1 is 56. When 5 repeats after every power, instead of getting 05 at the next power, it gets 25. Now we are very much aware that what are the cyclicities and all the tables, and this table also you can get in my PDF file that I have uploaded. Now we can get into questions and the method of finding.
Now that we have learned about tables and all those things which are needed before learning the method of finding the last 2 digits, so then my website last2digits.tk, in that I have given 6 nice examples, and I am going to solve all those and teach you the method of finding the last 2 digits of any number, any operation. So any operation. So the first question I have given in the examples, and if you want to go on to my page, below is written my page's URL. 16 to the power 6 one has to find. Now we have to make it into a plus b, where b is a single digit number. Is equal to 10 plus 6 whole to the power 6. And one thing that we all should try is, in this part A, unit digit as much as we could should be a 0, should be 0. It will help us to calculate, okay? Now, n a b to the power n minus 1 plus b to the power n. N a b b to the power n minus 1. It's 5 plus b to the power n. Now, what to do is, it would, see, using the above table, we found that it would be 60, 60. Above table says 6 to the power 5 has last 2 digits as 76. Plus, this has the last 2 digits as 56. Okay? Now, we can do this. It would be 4560 plus 56. Now, it would be 4616. 16 last 2 digits. Basically, what I done, dividing it, then NAB to the power n minus 1, putting the values to the formula, then solving it, and last 2 digits would be 16. Okay. Now, on example 2, I have given, let me see what's the question. The question would be, this is the printout of my web page, the whole web page I made. Now, the 134 to the power 73. Okay. 134 to the power 73. Now division would be 130 plus 4. We can't make it like 100 plus 34 because B should be a single digit. Single digit, right? Now 73. We have the formula N A. As we are working for the last two digits, we want to only solve the last two digits into 4 to the power 73 plus 4 to the power 72 plus 4 to the power 73. Now, next step. How would we solve this part? See, this would be 3 into 10. Whatever would be 3 into this number, the unit digit would become the 10th digit. Unit digit would become the 10th digit when multiplied by 10 because unit digit would become 0. In the sense, if we multiply 60 into 2, it can be written as 12 into 10. 6 to the 12, and like if we multiply this becomes the unit digit. After multiplying by 10, this becomes the 10th digit. This is a simple concept we are using for fast calculation here. So we just need the unit digit of 3 into 3. Then it will be 90. Now after into 10. Now what to do with these powers? See, the cyclicity of 4 is 10. Okay, divide these powers by the cyclicity. Now, 4 to the power 72 plus 4 to the power 73. Now, dividing 72 by 10, remainder is 2. 70. And then we would do 4 to the power. The number to the power, the remainder. 73 divided by 10, remainder comes to be 3. And 4 to the power 3 would do. That means it would be 16 and it would be 64. Now, this step we have done. Now what to do? Last digit we have found, the 90, we put the values. It was 4 to the power 2. Now, it will be 16 plus, it was 4 to the power 3. It will be 64. Now, last digit, it will be 54. We want the unit digit only 4. Okay, plus 64. Now, the next step would be addition. 4 and 104. Answer is 04 are the last two digits. Now, next question. Actually, this was the question that was making us aware how to use the cyclicities for bigger powers. We have to divide the cyclicity by the power. I mean the power by the cyclicity, and the remainder make the power of the base. And the result would be the last digit. Would give us the last digits. Okay. Now, next question. What is that? 196 to the power 41. Now, division would be like 190 plus 6 whole to the power 41. Then 41 into 190, because only the last two digits, into 6 whole to the power 40, because n minus 1 and 41. Now, what would we do? It would be 9 ones are 9 and 90. Next step. 6 to the power 40. Now 6's cyclicity is 5. It gives us a remainder of 0. And if we make the power of 6 0, it would give us the unit digit as 0 1. But the unit digit of 6 can't be 1. It can only be 6. So we can't make 0 as the power. And with no power, we make 0 as the power. We have to, then in the case what we do, I will take an example. If we say 6 to the power 5, last digit is 76. But as the cyclicity, using cyclicity, it divides it and gives the remainder 0. But the last two digits are 76. In short, we can say means whenever the remainder comes to be 0, we make the cyclicity as the power. Means remainder is 0 and 6's cyclicity is 5. We would make this power 5. And here it's 6 to the power 1. 90 into this 76. But here 6 to the power 1 should be 06. But the rules that we have studied says every repetition of 6 to the power 1 is 56 but not 06. Actually, the original number we can say is the repetition of 6 to the power 1. Excluding 6 to the power 1. It isn't 6 to the power 1, the original number. So it should be 56. Now, 9, 6 and 54 plus 56. That would give us 96. Last two digits. This is the solution. It was like the last question was like just clearing the idea. What's the idea of using cyclicity? Now this question gives us a case of cyclicity that is important to know. When the remainder is 0, what would we do? Simply put the cyclicity as the power. Now, next question. Now, concepts are clear. But how to use that concepts when you are struck by a question which is a little complicated. Now, next question is 134 whole to the power 145 into 563 whole to the power 831. See, we have to solve only the last digits, right? So just put like 34 whole to the power 145 into 63 whole to the power 831. Simplify. Now, first step, we'll go with this first and then this second. Okay, first 30 plus 4, 145. Now, 45 into 38 into 4 to the power 144 plus 4 to the power 145. Now the step is clear. Now 3 5s are 15. Last digit should be 50 into 144. Cyclicity 10, remainder will be 4. Now 4 to the power 4. What would it be? The last two digits would be 56. Now 4 to the power 5. Remainder is 5. 4 to the power 5. 24. Now, it will be 5, 6 and 30. 0. 0 is the unit digit. So 0, 0 plus 24. 24. Now, first step we got that it would be 24. The last two digit for this would be 24. Now second step. To the power 31. Second. 60 plus 3 to the power 8 to the power. It will be 31 into 60 into 3 to the power 8, 30 into 3 plus 3 to the power 31. Now it will be 60 into the cyclicity for 3 is 20. When we divide this, we get the remainder as 10. Then 3 to the power 10, last two digits will be 49. Here, 11 is the remainder. Now, 11 is the remainder, 3 to the power 11 will have the last two digit as 47. Now, we have this, we can go ahead here. 6 9s are 54. 40 plus 47 is here 7, here 8, 87. Now, we have the second term. It's not the answer. It's 87. Here we have into 87. Now, while solving this, wait a second, I have to solve. Okay. It would be 2088. 2088. The result came to be 2088. Therefore, the last two digits would be 88. Answer is 88 is the last two digits. That's what we solved. Now, next question. The next question I've given, I don't call it a good question because it has a very lengthy calculation. But I just was time passing and made that. But as I've given, I should solve it, right? So I will solve it. It's a very, I can say, idiotic question. But I can solve it. See, it has a lengthy calculation. 1, 0, 1. 888. Now, I would call it x because I don't like to write so long numbers again and again. Now, we have to find root 7 of x to the power, whole to the power 36. See, after prime factorizing it, I found this result. X is equal to 16 whole to the power 7 into 17 whole to the power 7. See, I will not solve it here. I don't have that much space. You can solve it as you like. It is equal to this. Now, I have to find first root 7x, that is 16 into 17, that is 272. Okay? It's 272. Now, we have to find 272 whole to the power 36. Now we can do all this and go towards 272 whole to the power 36. I can do this like 72 whole to the power 36 because I'm solving only the last two digits. Now 70 plus 2 whole to the power 36. Maybe I have done this in a different way, different manner. I have divided it into 270 plus 2, I think, in my page. This doesn't mean that it is a mistake. In simple words, in the next step, I have made it like last two digits only. But here I am just directly doing that. No problem is there. Okay, now n into a into 2 to the power 35 into 2 to the power 36. Now, it would be 7 6 42, 20 into remainder 20. This is cyclicity. Remainder would be 15. 2 to the power 15 would be 68. Or here remaining would be 16. It would be 36. Now we have to solve. Yes, this is the frequent mistake I do. Now 2 8s are 16. Last two digits 60. See, this method, in this method, we multiply the 10th digit of the number which has the 0 at the unit place. Not like 8 into 2 and we will do like that. Actually, that is giving the right answer, but sometimes we get mistaken. This is the correct way. 2 into 8 or anything, whichever number is there. Plus this is 36. Now 60 plus 36 will be 6. Here this would be 9. 96 are the last two digits. Now, next question is a very good question. The last question is a very good question. It's the golden question I have. It's the 6th question. This is 69 whole to the power 147. Now I can do it like first step would be 71. First, like you have to do it in this form, radical form, make it as an exponential form. That will make us easy to solve it. First step, exponential form we will make it. 69 whole to the power 147. 1 by 7. 1 by 7. Oh, here 240 will also be there. 4 to the power 240. I think it's 240 or 240. I don't remember. Yeah, 2401. Now, when we open the bracket, this would make it 71 to the power 7 into 69 to the power 21. Okay. Plus 7. It would be 2401. Now, next step that we do is open this, 71 into 69 whole to the power 3 to the power 2401. Now, what will we do? Next step will be 71 whole to the power 2401 to 69 3 7 2 3. This is. Now we have to solve this. Now can we remove all this and just write this? So 71 because it was the need to simplify it. You can't directly do that. 71 to the power 2401 into 69 whole to the power 7203. Now this is first step. Here's 70 plus 1 whole to the power 2401. Here what the thing we will do is 01 into 70 into 1 to the power 2400 plus 1 to the power 2401. Now 1 to the power anything is 1 and 1 to the power anything is 1. Any number multiplied by 1 is the same number. Here is same plus 1. It will be 71. We can go directly. Now we can put it as a value. Here 71. Now this is the next part. Here's 69. Second part. 69. We can write it down. 60 plus 9 whole to the power 7203. Now 03 into 60 into 9 whole to the power 7202 plus 9 whole to the power 7203. Now see the 9 cyclicity. Here first we solve this. 6. Here it's 0 is at the tenth place, not at the unit place. You can use that formula only when the 0 is at tenth place, a unit place. So here 6 into 3 80. Now here cyclicity is 10, so remainder will be 2 into 9 to the power 2 plus 9 to the power 3. Next step would be 80 into 81 plus 29 plus 9 to the power 3 is 29. Last will be just 29. Now 8 ones are 8, 80. That is equal to 80 plus 29. That is 9, 109. Here 209. Now 09. Okay. Now 9 ones are 9. But we can't do it now. We have to multiply it. Because 9 is 9, unit digit would be 9. It does not assure us about the tenth digit. So when we multiply this, we get 639. 639. 39 last 2 digits. This is. Now we'll see some facts and some important points related to it.
Now we're gonna read some important points. Last two digits for 25 to the power n and 76 to the power n would be 25 and 76 respectively, always. In the formula, a plus b whole to the power n is equal to nab to the power n minus 1 plus b to the power n. B should be always be taken as a single digit because the cyclicity only works on powers of numbers 1 to 9. That is, 6 to the power 7's last two digit would be 36, but 36 to the power 7's last two digit won't be 36 but 96. Go number by number while finding the last two digits of products, sums or differences or any other operation. For using the cyclicity of 2 and 3, remember the last two digits of 2 and 3 to the power 1, 2 and 3 to the power 5, 2 and 3 to the power 10, 2 and 3 to the power 15, 2 and 3 to the power 20 and multiply for getting other powers. For using cyclicity of 4, 8 and 9, convert to the powers of 2 and 3 and find the last two digits as per the fourth note.